All right, so I assume there are questions about current sources, which we'll cover. But before I do that, are there any questions on anything else? Any other parts of the homework? All right, today's quiz, I don't know, should be pretty easy, but what do I know? Everybody's comfortable with the problems that were there. No one needs me to see me work for it. See, education's the funny thing. You're paying for it, right? But if you get ripped off, very few of you will complain. Right? It's like buying a car with 3 wheels. Oh, I got a car with 3 wheels. No one would tolerate that, right? But if you come in, if you don't understand this, I'm sure somebody else doesn't, and I will work it. You just need to tell me. You want me to work it? First one? Well, I'm going to work all of the ones with current sources in there for you. Yeah. All right. I'll assume that the first one is easy and everybody knows how to do it. So I'll ask just real quick to satisfy myself. What is the current in the 1K resistor and why? What is the current in the 1K resistor? 1.5 milliamps. Okay, why? Yeah, the voltage across it is 1.5 volts. I put a voltage source across it. Okay? All right, so let's go through, and I'm going to work every single one of these problem 2 problems just to make sure everybody's grounded well. Then we're going to move on to some new stuff. So let's start out. I have to draw it. I can't switch over, so give me a second. So I should have covered current sources. They're pretty straightforward, and I just forgot. So that's why you had an easier homework assignment, and hopefully the grader knows that. I'll try to tell him, if not. And 500, 2 milliamps going down, and V1, V2, 1.5. All right, so here's the circuit for the first one. And let's make it big. And I ask, okay, so let me tell you, this is a current source. It just means 2 milliamps is flowing in that wire. All right? So if I ask you, what's the current flowing there like that? 2 milliamps. If I ask, what's the current flowing down there? 0. If I ask, what's the current flowing like that? 2 milliamps. If I ask, what's the current flowing like that? Minus 2 milliamps. Everybody follow? Any questions on that? So, if I ask, what is the voltage drop across the resistor? Now, I'm not asking what V1 and V2 is right now. I'm asking you, what is the voltage drop across the resistor? It's going to be, I have to define it first. Now, I already drew an arrow there, so I'm going to define it like this, right? Does everybody see that? I'm not afraid to define it. So I defined it like that, and the current's flowing like that. So that's Ohm's law. That's this. We got it? So what is that voltage? Let's go. V2 minus V1 is equal to 2 milliamps times 500, which is 1 volt. Any questions? So in terms of V2, I'm going to bore you, and I want to bore you because I want everybody to get it. In terms of V2 and V1, what is the voltage across the resistor? V2 minus V1. Now, what is V2? How do you know? It's connected to a voltage source to ground. If he takes points off for that with you writing that, that ain't right. Okay? So, if I come over here, here I am sitting up here, and I'm at 1.5 volts, you just told me, and then I run over here to V1, am I going uphill or downhill? Downhill, so I get that V1 equals V2 minus 1, which you're saying, hey, dude, you just rewrote this equation, V2 minus V1 equals 1, but I'm looking at it a different way. or I'm at V2 going down by the 1 volt voltage drop across there. And so I get V1 is equal to 500 millivolts, or 1/2 volt. So I put a box around this one, I put a box around this one, and I say, does that make sense? So now I say, what's the voltage drop across the current source? Give me 2 answers. What is it? It's V1 or 1/2 volt. Now I'm asking you this because I don't want any of this to be challenging. I went over there, here I am now. I'm at V1 and I look and I say, oh, what is the voltage drop across the source or across the current source? It's the same as the voltage drop from here to here, as I wrote plus and minus, but isn't that the same as the voltage drop from here to here? It's one wire. Isn't that V1? When I say V1, that is the voltage that I'm calculating there. Does everybody follow that? Does that make sense? Now I'm going to ask a stupid question, but I don't do the simple stuff and then everything's easy. If I ask you in a test, I say, find Vx, and I define Vx as that. With what you know right now, what is Vx equal to? Minus 1/2 volt. It's 0, this voltage, the plus terminal, minus the minus terminal voltage of 1/2. Yay? Okay, ready to move on? Does this make sense? Is anybody like, I don't know what the hell, you got plus and minus in here. If I give you the quiz today and I put something on there like this, no one's going to miss it. Everybody's going to get 100 because we want to give everybody A's. The A's?
So the voltage drop is V1.
The voltage drop is from here to here with plus to minus is V1. So when I write V1, it means this wire's the plus, and then I go to ground. So if I go over here V2, it means this wire's the plus, and I go to ground. It's a sloppy way, and it's the way it's done in industry. They say this is the voltage, and then they know that's where the plus terminal is, and then you go to ground, and that's your reference. That's where you put your meter and you measure the voltage. Okay? Making sense? All right, let's do another one. And let's do, and I have to copy it. I should have printed it out, but I didn't remember. So let's do we want to do this one? Let's talk real quick. What is the voltage V1? 1. What is the voltage V2? 1.5. So if I define the voltage across this resistor as plus and minus, what is the voltage across the resistor? 0.5, 1.5 minus 1. If I define it as plus and minus like this, what's the voltage across the resistor? Minus 0.5, it'd be 1 minus 1.5. Easy, right? All right, so let's go over to this one right here. Let me sketch it down. And while I'm doing that, what is V1? But what if I labeled that voltage source? Yeah, the answer is minus 1.5 is V1. But what if I labeled the voltage source on today's quiz so that that was a minus 1.5? Then what would V1 be? Yeah, positive. Ah, you're getting it. Good. All right, and that's a 5K. And this is a V2 and a V1. And I think I copied that right. And you just told me that V1 was equal to 1.5 volts, right? Oh, negative, yes. I was checking, testing you. Yeah.
So if the current was going the other way, it'd be a positive 1.5.
Wait. That's a good question. So if I flip the current around the other way, does it change the voltage there? No. Remember, first thing I taught you, when you see a voltage source to ground, burn it into your brain. The voltage on the other side of ground is the voltage source. That's what you're seeing right there. Positive's grounded, minus is at minus. It doesn't matter what's happening in the rest of the circuit. All right? Make sure when you're grabbing your homeworks that you don't take two. All right, sometimes you'll grab them and not look and they'll be inside each other. Okay, so now, here's the thing. I'm going to ask you what V1 minus, what's the voltage source across the current and all that. But let's do the easy one. Tell me what to do. This is on the quiz. Your brain's freaking out. These quizzes give me stress, raise my blood pressure. What do? I'm looking at this. I write this down. Okay, I put my 0. Now what? I'm going to draw my currents and then through the resistor. So I'm not afraid. I'm saying, hey, I'm picking this current like this. Could I pick it the other way? Sure. Then I'd get a negative current. I don't want to do that. So I'm going to pick it this way. Now I'm going to pick this voltage like this, and I'm going to label that plus to minus as what? What am I going to label that? I just put it as V2. By definition, that's what V2 is. It's the voltage from the plus to the minus. Then I'm going to say this current is equal to what? 1/2 milliamp. Then I'm going to go over here and I'm going to say V2 equals 1/2 milliamp times 5K, which is 2.5 volts. Now I'm going to, any questions on that? Now I'm going to come back here and I go, what's the voltage Vx? Voltage on the positive side is what? 1.5. Minus 1.5. Voltage on the negative side is what? So what is Vx equal to? Any questions on that? Okay, what if I write minus plus Vz? And I say, what is Vz? Be V2 minus V1. This was V1 minus V2. And that's equal to V2, which is 2.5, minus V1, which is minus 1.5, or 4 volts. Any questions on that one? Easy? All right, let's do one more. Are you sure it's making sense? Because trust me, it's going to get complicated fast enough. Yes.
So for placing your plus and minus, it's this for your current source. It's the same thing as with your resistor. You can set it however you want.
Yeah, you can do whatever you want. Yeah.
Okay.
So I picked it like that. Of course, if the problem says, if I draw a plus and minus and I say find Vx, you can't do it. Oh, screw you. I'm going to do it my way. Yeah, I didn't ask you to do it your way. I want you to find Vx. Okay. So then let's go, and you tell me which one you want me to work. How about one of these? How about let's do all 3 of them? Let's do this one real quick. All right. I don't want you to say instructor did not work enough examples. All right. So one of the things I'll do is I'll show you multiple ways to work a problem. And as we go through the semester, because I don't want you to know just one way. And that's called V1. And one of the comments I had, I don't get this, I think I've gotten it once, but I got on my teaching evaluation was, he teaches me more than one way to solve a problem. I don't like that. I want to know one way and one way only. I literally laughed out loud when I read that one. Anyway, all right. Tell me what to do here. Okay, so I heard a lot of talk. What was it? What could you do? Combine the resistors. It's a current divider. That's why I wanted to go through. That's why I said let's do all 3. So wait, I'm going to pause and let's write the voltage divider equation first. So if I have a voltage divider, let's call this V in. And let's call this R2, R1, and V out. What is V out equal to? You should memorize this. V in times R2 over R1 plus R2.
Why R2?
Because this is the voltage I'm getting across right here. If I wanted the voltage across R1, it would be R1 divided by R1 plus R2. You need to burn this into your head. It's like Ohm's law. You use this all the time. Okay, I see some perplexed looks. Looking at that answer, tell me, in that lower circuit, how much current flows in the circuit? What is the current that flows? This is something you should know. Maybe I'm not assigning enough homework. It's Vn over R1 plus R2. Does everybody see that? So do you see there in the equation, I got V out equals Vn over R1 plus R2, which is the current, times R2. Does it make sense now? Make sense? Okay, so now let's go back over here. I'm going to do this generic. So wait, if I wanted the voltage across like this for R1, what would I do different? I just said it. It would be R1 times Vn over R1 plus R2. Okay, so now here, I'm going to do some simple stuff and you're going to help me. I'm going to call this current I1, this current I2, and I'm going to ask you, what is I1? What is it? Now in terms of V1 and I1, in terms of V1 and R, let's call this R1 and R2. No, not in terms of numbers, just leave it generic. In terms of V1 and R1, what is I1? Everybody agrees with that, right? Okay, what is I2? Everybody agrees with that, right? How are I1 and I2 related to In? Does everybody agree with that? And what was the law that I said? Here's a node, which is a connection of wires. Current goes in equals the current that goes out. And what was that? Kirchhoff's current law, KCL. Whoops, what happened? Everybody agrees with that? Would you then agree that I could write In equals V1 over R1 plus V2 over R2? V1? Everybody would agree with that? Okay. Let me draw a little box around this so we don't get confused and put voltage dividers so when you look at the notes later you'll remember. Okay? So now if I go further and I say, all right, well what if I want to find I1 in terms of In or whatever? What do I do? How can I simplify this circuit? Okay, we'll do that. We'll write In equals V1 over, I'm going to use some notation. You tell me if it makes sense. R1 in parallel with R2. So R1 in parallel with R2 equals R total, which equals R1 times R2 over R1 plus R2. Or R total equals 1 over R1 plus 1 over R2. I'm just writing things differently. Just repeating. Any questions about any of that? Okay. So I'm going to come back here and I'm going to write this little meter. And I'm going to write the circuit again. And I'm going to draw a little more generic In, R1, I1. The reason I'm doing this is we're going to get an equation we can use, so simplify life in the future. I2, and then I'm going to write here that I in, what I just derived was V in over R1 in parallel with R2, which is V1 over R1 R2 divided by R1 plus R2, and this is V1 and that's ground. Before I flip over, are there any questions? See, this is why doing lectures on the whiteboard are good, because I can do something and I can go all the way across and go back, and it's good. Okay. Whoops, got two number 3s. All right, so let's say I want to find I1. What is I1 again? V1 over R1. And if I take and I solve for the V1 here, don't I get V1 is equal to IN times R1 plus R2 all over R1 times R2? Anybody agree with that? Oh, whoops, I got that backwards. That would be V1 equals IN times R1 in parallel with R2 over R1 plus R2. How's that? Better? Now, if I plug that in here, now you're like, hey, he's doing derivations. I don't like that. We're almost done. If I plug that in there, I get I1 is equal to R2 over R1 plus R2 times IN. Boom, done. That's our current divider equation. Tell me what, this is the way I used to remember it when I was in school. What's the difference between that and the voltage divider equation? Yeah, use the opposite resistor. So if I want to find I1, I don't put in the numerator R1, I put R2. Remember that, because I can guarantee in 3 weeks or so someone's going to go, why are you using R1 there, R2 there, when you should be using R1? Okay? So any questions about that? Yes? No, just for when you have a current that divides. And so that's what I was going to do. I'm going to put here, this is the current divider equation. And what is I2 then? Questions about that? Yes? Yes, there is. Let's write that one down too. Then I'm going to give you a quick 2-second tutorial in algebra to help with how I do algebra quickly. And then we're going to go back and do those problems. So if you have the following. R2 then you get I3 equals IN times R1 plus R2 plus R3, and then you take the R3 out and you put R1 in parallel with R2. So it's the same thing, all the resistors in parallel except for the one that you're trying to find, you just remove. Yes?
And the R1 parallel with R2, that's equal to the R1 plus R2 over?
Yep, that's R1 in parallel with R2 is equal to R1 times R2 over R1 plus R2. All right, let's go back to the problem, but I want to give you a quick algebra tutorial here real quick on how when I'm doing up here and I'm doing math, how I think about it. And I'm probably, has anybody heard my tutorial before, my bead analogy? All right, so we're going to do that. So when I have an equation like the following, A over B, C equals B times A plus D all over X. I have something like this, and I just used it when I was doing the parallel equations. I don't think math. The way I think about this is I think of there being beads and wires. And so I think of there being a wire from here up to here and a wire from here up to here. And this works for me, and it may work for you, it may not. But when I look at it and I say solve for X, in my mind, I slide this bead up, and I slide this bead down, and I slide these two beads up, so I get BC times B times A plus D. So you see how that works? I don't think math. I just think I'm going to move this bead up, move this bead down. So when I was doing, the moment ago I was doing, I forget what it was, like this, IN equals VN or whatever it was, all over R1 times R2 over R1 plus R2. The way I thought about solving for RVN was I just move this bead, that's a whole bead, I just move it up there, and I immediately write VN equals IN times R1 times R2 all over R1 plus R2. And I'll try to mention this as I go. But I found if you don't think math and you just think of moving this around, your brain doesn't get cluttered, and it's easy to do things. And then, wow, you solved that fast. Yeah, I did. Does everybody follow that? Okay. Well, you got to do cross multiplication. You got to divide both sides. Or you could just move the bead up. It's the same thing. All right, let's go back to the problem at hand. So it's this one right here, 1.5 milliamps, and I bet you can solve it without even writing anything down. First question, how much current flows in each resistor? By inspection. And why? What is it? Yeah, so it comes in, and I've got 3K and V1. What do I know? The two 3K resistors are the same, right? So 1.5 goes up to the top, and what does it do? Splits and goes down each of the resistors. But without thinking too deep, what do I know? Because it's the same resistor value, and they got the same voltage across them. It's going to be half. So I got 0.75 milliamps, or 3/4 of a milliamp flowing down each leg. Does everybody follow that? Let's prove it using our current divider equation. Let's call this I1, I2, and I write I1 equals 1.5 milliamps times this 3K all over 3K plus 3K. And of course, what is this term simplified to? 1/2. This 3K all over 3K. No one's playing with their computer, right? All right. Does that look good? And so they're both equal to 0.75 milliamps. 0.75 milliamps. Any questions? That homework was too easy. Everybody's concerned with their grades on their homework and quizzes, huh? That grader's a hard ass. All right, let's do another. Everybody understands this one? All right, let's do another one. I'm either doing a really good job or you guys aren't telling me when you don't understand. Let's do this one right here. I don't understand, but I got the video and I'll review later. So say you become a professor or you're an adjunct and you teach a class. It's 3K. And you're like, I really liked videos, but you don't want to use videos because you're afraid you're going to do something wrong. Do you think when you teach a class for the first time or even for the 5th time that you do everything perfect? So it's okay to be wrong. It's okay to make mistakes. Okay, that's part of learning. You shouldn't feel bad. I made a mistake. So what? Try and don't, the thing you don't want to do is, because you will teach, some of you will end up teaching, you don't want to act like you know everything, and when you make a mistake or you don't know, act like you still do. Just say, I don't know, but I'll find out. Okay? and be relaxed. And if you care about the students learning, that's what matters. Okay, tell me how to approach this problem. There's several ways. Well, I mean, I could redraw the circuit, but somebody said it, you can combine the resistors, right? Does everybody agree with that? So I could write, let's write it directly. Or actually, because we're learning, let me write a little bit slower. So it's 750 in parallel with 3K. And then this is going down, and I'm going to be lazy. I'm not going to draw the grounds connecting each other. And I'm going to call this V1 right there. And I want you to write V1 is equal to what? It's Ohm's law. There's V1. Wait, before we go any further, does everybody agree that's V1? The way I've drawn it? Okay, but I don't have the current going down here. Which way is the current flowing? So what's V1 equal to? Negative 1 milliamp times 750 times 3K all over 3750. And let me think, could I do that one without a calculator? What's 750 divided by 3750? What's 4 times 750? This is a good thing to remember. So what's 5 times 750? So what is this reduced to? And what's 3K over 5? So what's the answer? Anybody agree with that? Milli. Oh, wait. 600 millivolts. 600 times 1 milli. 600 times 1 milli is 600 times 0.001. So I move the decimal point one way this way, one way this way, one way this way, one way this way, one way this way. Now this is just 1, and this is 0.6. 0.6 is 600 milli. Where's my calculator? All right. So now, next question. You can use the equation. Well, let's ask that first. If I use the equation and I calculate the current in the 750 ohm resistor, what is it? Let's write it. What is this current? 1 milliamp. Oh, the notes are going high today. If I want this current, it's R1, it's IN times R1 divided by R1 plus R2. So if I want I2, it's R1 over R1 plus I2 IN. So if I go back here now, and I ask, what is this current? Times what? 3K all over 750 plus 3K. Remember, it's the backwards. And what's this current? Does that make sense? See, I need to learn everybody's name. That's why I need to get to class earlier. All right. You know the other way you could look at it? What can you, just by knowing that the 750 ohms is 5 times smaller than the 3K, what can you say about the current flowing in that 750 versus the 3K? 750 is going to be 5 times higher. Because the 750 and the 3K both have the same voltage across, and the lower resistance will have a higher current. Any questions? We're going to do one more, then we're going to move on. We've got about 20 minutes till the grade booster. Yes?
Do the currents, you do it the opposite way, so why is it 1 milliamp?
Oh, it's minus, thank you, yeah. I wasn't even paying attention to that. Wrong, -3. Okay, let's do the last one from the homework, which is this one right here. Uh-oh, I'm scared. Well, not really, but it's fun when I used to be. Would this be an unfair quiz question today? All right, let me sketch it. That would be 1.5 milliamps. And then this would be 2K. And then we've got another 2K. And then a minus plus. And let's find all the voltages and all the currents in the circuit. V2, V1. Take a mental shot of that with your mind's eye. And then let's flip it over to here. Is that correct? All right, I'm learning. So what do I write first? 0. Now what? V2 is -1 volt. Anybody disagree with that? Okay, I don't know what V1 is, but tell me what I can do here. I want something super simple. I want them to do a KCL, but what's something simple that I can do at this point? No, I can't do a voltage divider because I've got two currents. When the current comes here, it's split, so that doesn't work with the voltage divider. I mean, really simple. I could label this resistor's voltage what? V1. It's already labeled. Then I could label this current here as what? Let's see if we can skip a step. What is that current? V1 over 2K. Now what? Doing the same exact thing I just did. Yep, I can go that and say this current is what? V2 minus V1 over 2K. And I know V2 is -1. Okay, does everybody see how I'm approaching this? Okay, so now I've got everything ready. I'm done. What's the last thing I need to do? Before I do that, what do I need to write? Here's my node. This wire, I'll just draw a small circle. What can I do at that node? Kirchhoff's current law. What's the current going in? I've already labeled it. What's the current going out? Any questions on that? Okay, you see how I didn't, I'm going to use that. I don't know, that doesn't follow. That's not a circuit that uses the voltage divider or the current divider. So I did it nice and slow. 0. Oh, that's labeled V1. Voltage across the 2K, V1. Then I go, okay, now that I've got a voltage across the resistor, I draw the current. Then I go up and I go, oh, that resistor is a little harder because the current through it's going to be the voltage across, which is this voltage minus this voltage. And I write that. And then I go, oh, now I just sum the currents going into the node. They equal the currents going out. Boom. One equation, one unknown. Any questions? Does it make sense? Okay, here's a little secret. When I do it, it looks easy. So when you get ready to study for the test or whatever, make sure you don't look at me. Take this stuff and do it on your own, and then when you get stuck, come back and look. Because when I do it, I can tell you, I watched your videos and I got an F. You got to work the problems on your own, because I know what I'm doing and I know where I'm going, and I make it look easy, and it's not when you're learning. Any questions before we move on?
Which way the current's going in, so I set up the equation.
Yeah, I could pick this around, and then it would be 0 minus V1 over 2K. It'd be the same exact answer. Someone had a question back here. I can pick the currents and voltages any way I want. I could say, hey, I don't like that current going this way. I want the current going that way, and there would be minus 1.5 milliamps. All right. Oh, how's that for a bunch of good stuff? So let's go back here, and then let's look at the homework that's due on Monday. Does this look familiar? Voltage dividers, and if it says can't find the currents, assume clockwise direction, you should be able to do these no problem. They're not to trick you. They're there to make sure you learn and that you can do well on the quiz. Okay? What is Vs minus Vx right here in E? 3.5. What is Vx minus Vs here in E? Minus 3.5. All right, if I go through and I say, what's the current flowing down this resistor? Now keep it simple. In this direction, what's your response? Vs over 1.5K. What about the current going down in this direction? Vx over 500. What do we know about the current in the clockwise direction that flows? It's the same. It's one circuit, circuital. Let's go to a harder one. Well, not really. Okay, here's number 2. What's the three 1.5Ks in series? Okay, what did I tell you? And I did this today in lab this morning. I did a digital to analog converter, and we were going through and combining resistors of like value, and I had lots of students in there that took circuits with me, and they were like, ugh. So when you have like resistors in parallel, what do? Divide. So if there's three 1.5K resistors in parallel, what's the total resistance of the three? 500. So now I got, oh, well, there's 500 here, and I got 1.5 volts, and I've got a 500, a 500, and 500. I can find those voltages. What's the current that's flowing in all of these? Let's see if you can get that in your head. 500 plus 500 plus 500 is 1.5K. That 1.5 volts drives 1.5K, so what's the current? 1 milliamp. So what's the current flowing in R3? 1 milliamp. What's the current flowing in R7? 1 milliamp. What's the current flowing in each of these resistors? Third of a milliamp. Again, not trying to trick you. This is your homework, and you'll be able to go through it. What is the voltage Vx using the voltage divider? 500 millivolts. Got 1.5 times 500 divided by 1K plus 500. Again, not trying to trick you. And then this last one, show how to derive the voltage divider and the current divider. We just did that. I want you to know how to do it. I don't want you to just use the equations. I want you to know how to derive it. It's not hard, and you have it in the lectures. Okay? Everybody good? You doing all right there, man? I'm in pain. All right. All right. Let's go back now and go to our lecture notes, and let me look at this. I want to do a spice list. I want to write that because I think in the next homework you have that, and I want to work some examples, which I've been doing. We got about 15 minutes till our grade booster. So let's go get a circuit, and I want you to be able to write a spice net list. So let's pick one. Let's do something simple to begin with. Let's call this 1.5 volts. And then let's go here with two resistors. We'll call this 1K and 2K. And then let's go over here and let's put a resistor to ground of 5K. And I want you to handwrite the SPICE net list to simulate this. And I'm going to do it, then we're going to simulate it, and we'll make sure that it's correct. Okay, so the reason I want you to know how to do this is if you get a job in circuits or doing chip design or whatever, and you don't know what the future brings, and you know what's important, being employed and making money. Okay, so when you get a job and you're using the tools, you need to know how they operate. And they don't talk to each other magically. They use like a text file, like I'm about to show you. When you have a schematic, it generates a text file and sends it to the simulator. They're not actually the same program. They're different programs that talk to each other. So when they do that, it's called a net list. And you probably, if many of you have probably taken like a digital class or 2 or 3, and you've probably done like Verilog or VHDL and coded some a bit. It's going to be similar to that, but it's going to be a lower level because you're describing individual components. So what I'm going to do, I'm going to just, for my sake, I'm going to label the nodes here. I'm going to call this node V1 because I don't want just magical nodes. I'm going to call this V2. I'm going to call this resistor R1, this resistor R2, and this resistor R3. And I'm going to write the net list right now. One thing that you need to remember when you write a net list, the simulator ignores the first line, and that can be really irritating if you don't remember and you're doing something manually and sending it to a tool and thinking it's looking at the first line. It ignores the first line. So I'm going to put in for this, my net list is the first line. Then I'm going to write, and it doesn't matter the order, and in SPICE it's not case sensitive. I'm going to write V1. I'm going to call this voltage source V1 the same as the node. From the node V1 to 0. Guess what 0 corresponds to? Ground. All SPICE simulators use 0 for ground. Where could you possibly make a mistake here? Calling that O. Now, I've never done that. Yeah, I've done it a few times. All right. DC 1.5 volts. Of course, I learned Fortran. And Fortran, you put in the 0. Fortran is formula translation. Here's something good for you. Everybody's heard of BASIC? What's BASIC stand for? Beginner's All-Purpose Symbolic Instruction Code. Have you heard of COBOL? Common Business-Oriented Language. Fortran, formula translation. I learned something today. All right, I could put spaces in here, but I said there's a voltage, V1, has to start with the V, which from node V1 to node 0, it's a DC voltage of 1.5. Then I'm going to put a resistor R1, and let's go out of order. R3 from V1 to ground of 5K. A resistor R1 from V1 to V2 of 1K. A resistor R2 from V2 to ground of 2K. Then I'm going to put dot end. Does everybody see how I wrote that net list? And now I'm going to simulate. Before I do, though, just to simulate, it's not that interesting. With your newfound circuits knowledge, I'm going to ask some simple questions here. I don't know if they're simple. What is the current flowing there? Yay, I love it. And what's that equal to? Which is 1/3 milliamp. No? Did I do it wrong? Let me see. So this is 5 times 0.3. So the 5s cancel, the 3 moves up and becomes milli. Oh, you're right, it's 0.3 milliamps. We agree? Does it bother you I'm not using a calculator? All right, so what is the voltage here, V2? Well, what's the simpler? What's that voltage? 1.5. So here's what, if I was in industry, I'd go, oh, well, this is 2 times bigger than this, so I'm gonna get a volt across that and a half a volt across that. So I'll get a volt like this, and since this is half the size, I'll get half a volt like that. But I'm learning, so I'm not gonna do that. What I'm gonna do instead is say 1.5 times 2K over 2K plus 1K is this voltage, and that is what? That's equal to 3K, 1.5 times 2K is 3K over 3K, which is, and the reason I'm doing this, I just want to be able to look at the voltages and currents. What's the current flow in those 2 resistors? That current would be 1.5 over 3K, or half a milliamp. Going too fast, man. Gotta hit the pause button. All right? I don't want your brains to get bogged down in nonsense. That's why we think about beads and water flow and going downstairs and upstairs rather than equations and math. All right, can I proceed? Any questions? Is anybody wondering what's on the quiz today? He was evil. He gave quizzes, so I had to go to class. Why didn't I just watch his videos on ×1/2 or ×2? Okay, so let me go here, open this, and do File, Save As, and this is lecture. Let's just call it Lecture 3, Example 1. Do a Control A, delete, and then I'm going to put my net list. And then I'm going to be V1, from V1 to ground, DC 1.5. R3 from V1 to ground of 5K. R2 or R1 of V1 to V2 of 1K, and R2 from V2 to ground 2K, and we really don't need this one. I'll put dot in. Does anybody agree that I did this correct? Now, would it be unreasonable for me to give you a circuit and say write the SPICE net list for this? I mean, if it's just voltage sources and resistors. I don't think so, but I'm sure some of you would not agree that that's a reasonable quiz question. What the hell is this? That was hard. All right, so I hit File, Save, and then let's go back over here to LT SPICE and File, Open, and then let's go here and do All Files. Go grab my SPICE net list here, and hey, I can edit it directly in LT SPICE. Now, especially when you take the digital chip design class from me, I'm a big fan of being able to use your tools and knowing how to use the tools, especially if you're a computer engineering major. You need to know how things are operating and not be a button pusher, okay? Button pusher, All right. Because then you have to wait for someone to help you, and waiting for people to help is not good. That's why my neighbor's AC went out last weekend, and I walk over, and because I know a little bit about AC, and I'm like, well, did you check the run capacitor? So I took it apart, and I'm like, yeah, I think it's the run capacitor. Do you have a spare? No. I'm like, it's like $10, but if you have somebody come and fix your AC, it's like $250, and then you get screwed. You keep run capacitors? Like, yeah, because that's what are the most common things that break in ACs. Run capacitor. 70% of all AC repairs are either the run capacitor going out or the fan motor. So if you can replace those, most of the time you don't need to call anybody, and it's not that hard. All right, my professor's crazy. All right, serious, I don't like to be ripped off, man. Coming like, oh, well, let's charge you $500 for that 15 minutes of work. All right, no analysis. Oh, I forgot an analysis. Let's do a dot tran for 1 second. Run. And then what did we say the V2 was? 1 volt. So I'll go up here to this and I'll write V2 and it's 1 volt. Then I said, what is, let's add the plot plane. And then I said, what is the current through R3? And we calculate 0.3 milliamps. And there it is. All right. And then last but not least, we'll pick one of the currents through the other resistors. And it was 0.5 milliamps. So what do you think the current's going to be through the voltage source, the 1.5 volt voltage source? 0.3 plus 0.5 or 0.8? Let's find out. V of, wait, before I click the button, is the current going to be positive or negative when I plot the current through V1? It's positive the way I calculated, but what's SPICE going to tell me? Negative, because SPICE defines positive current flows from plus to minus, and I defined it as going out like this. Okay? So let's see, 0.8 minus 0.8. Whoops, I don't want that. I want I of that current. Sorry. I of V1. And then let's right click over here so we get a better grade. And let's go to, how about -1, and then the top we'll put it 0, and the click we'll put it, yeah, that's fine. There, and then we'll do a Control G. What do you think Control G does? Put the grid on, styling. All right, now save this, save this. Any questions? I'm gonna do one more quick example. All right. One more and then we'll do our quiz. This one's going to be pretty straightforward, but I want you to tell me how to work it. And is everybody okay at this point if I don't draw the wire there to close the circuit? It's understood. I'll go ahead. It's understood it's there. I'm just being lazy. And I want you to find every voltage and current in this circuit. And there's only how many currents? One. So since we're running low on time, yeah, we're not. Let's be crazy. Let's define the current like this. Tell me something easy. Something else easy. So far, I'm not challenging you, am I? I apologize. I'll challenge you later. Now what? This is where you need to do something that's independent. Define the voltages. I define the current flowing like this, so I'm not going to feel afraid. I'm going to define this voltage like that, or going plus to minus. And I could define it as plus to minus like that, but I just don't like it, so I'm going to define this voltage like that, just because I'm going crazy. Then I'm going to define this as V1, this is V2, this is V3, and of course V3 is equal to what? Now I'm going to call this current, crazy enough, I. Anybody have questions? So tell me something else simple that I can do at this point. What? So what is the, let's do something simple. What is this voltage from here to here? V1. What is V1? The current going from minus to plus. Minus, well, I don't know what it is. I got to solve for it. Minus I times 1K. Anybody not follow that? If I put plus minus like that, then it would be minus V1. And then I would have the voltage drop from plus to minus would be positive I. But does anybody not follow this? The current's going up like that. Shall I proceed? Okay, now what? Someone had a question?
Yeah, I don't understand on that. Isn't V1 reference from the ground?
Yeah. So I said V1 is this voltage, which I've labeled V1 minus ground. That's just the way I defined it.
Oh, okay.
Right? V1 minus 0 is this voltage. I'm trying to make sure that you're not used to, because for some reason I was the same way when I was learning. When you see voltages here and here, they're stuck in your mind that they're rigid and they're here. You don't realize, hey, there's a wire and they're down here and that's the voltage down there. And I'm trying to get it so you get used to going, oh, it's over here, but it's also the same over here. You follow? It's easy once you got it, but it's a different way of thinking. It's like algebra. Algebra is easy once you got it. Until you get it, it's not. Okay, so tell me what now to do. What's the next thing I can do? I can write, we're running out of time, I can write the voltage across here as I times 1K. Because the current's going like this, and I just simply use Ohm's law, and it's this 1K resistor times the current flowing in the circuit. But I can also write that as V2 minus 2 volts, or V2 plus 2. Does everybody follow? So we're almost done. We're going to get out our running shoes now. Tell me when to proceed. Okay, so I'm going to just start running. So here I am, I'm running. Which way do you want me to run? How about let's run like this? Am I going uphill or downhill from that plus to minus? Minus 2. So you're telling me now I'm up here, I've gone downhill, I'm at minus 2 volts? Yeah. That's one of the funny things that when you testify in like litigation, the lawyers, they try to trick you and they'll say, you're telling me that you want me to tell the judge or the jury the blah, 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 blah. I absolutely want you to tell them that. They're like, oh. Or the other one they try is is that right? And then there'll be like long periods of silence where they won't say anything to try to get you to feel uncomfortable. Hey man, I'm getting paid. I love silence, no problem. Another thing, if you ever get arrested or have court, relax and get an attorney. Don't say anything until you get an attorney. I'm getting all kinds of, it's serious, all right? Doesn't mean you're guilty, but you don't know the law and you don't want them to manipulate you. All right, so I'm up here at 2. Then I'm going to go this way, and I've drawn this minus and plus. Am I going to, and I'm just going to use this, minus to plus, am I going uphill or downhill? Uphill, so I'm going to put plus, and then I'm going to put I times 1K. Then here, am I going uphill or downhill? Uphill, plus 1 volt, and then the way I've drawn this here, am I going uphill or downhill? Downhill, and I've written the voltage as minus times 1K, because the way I've drawn this, I could just put V1 here as well, but the way I've drawn this, I've put plus and minus, and it ends up being that the current is negative, and so when I run around, so it's actually a positive the way I have it drawn. So here I am, just to make sure everything's understood. I've labeled that plus to minus, so I put the minus there. And then I've already labeled V1, so I could put minus V1 if you like that, or I could substitute what V1 is and have that there as well. And that's equal to 0. Any questions? Are we ready? All right, let's do our quiz.